Hello, everyone, and welcome to the fourth episode of writing an in-memory key value database. So far, we've reached to the point that we've written a program which accepts some commands like add name emod, and then I can say get name, and it will return emod for me. And so the implementation was based on hash tables. We implemented everything from scratch ourselves. If you have not watched the previous videos, you have to watch them, otherwise you cannot follow the concepts. But now, in this episode, we're going to try to tackle the challenge of resizing the hash table automatically when more key and values are being added to the database, to the hash table. If you know, right now we have this fixed size of a hash table, which probably is 8, so you cannot really add more than 8 key and values. Let's just try it. 3, 4, add 4, 5, add 5, 6, and 7, 8. This should be the last one. Yeah, exactly. So you can see 1, 2, 3, 4, 5, 6, 7, 8, and the last one is not working because it is a fixed sized kind of hash table. So we are going to try to solve that challenge. The reason that we put a fixed size kind of thing is that the program should be really optimized in terms of memory allocation and memory consumption. Because if you just put it as a open-ended kind of let's say data structure that you can store whatever you want in there, you have to probably specify a very high number like 1 million, and user probably will use only 2 slots of your database and add just 2 key and value pairs, and then the other slots, other memory spaces that you have allocated to your program is going to be like wasted because it's not being used. So that was the reason that we want to resize our table or extend the size based on the number of key values. There is a very good concept called load factor, which will gonna be something like a threshold for us that we determine based on that load factor if it's a true moment to resize our table extended or not. So that's the whole point. That's something that we're going to try to solve in this session together. Let's just start quickly with our hash table or ht.c file. And as I explained it to you, we have this 8 table size, which cannot really store more than 8. But here we have to really fix this now so it can resize itself based on the load that it's like getting from the user. So let me just start by defining a new struct maybe, and I will call that I'll call it hash table. Okay, or maybe it's better to just do it like hash table. I'm not sure how is it in the C. Let's just search. I will write CLang convention for struct naming. Camel case to separate wars. Okay, that's good. So the first one was correct one. I'll go with hash table. And inside of that struct, I'm gonna store some properties. First of all, I want to know how big is my hash table. So it's gonna be an integer. And that's gonna be like 8, 16, or whatever. It's gonna show how long or how big is our hash table. Then I'm gonna store something like a count at how many occupied entries we have in the hash table. That's needed because I have to calculate the load factor later based on this count and size. And then I will store the entries like this. Yeah, that's true. I'm gonna ignore this to do for now. I'm not gonna tackle this in this session. This is gonna be another probably topic. But for now, this is the new hash table that I'm thinking about. However, I want to now create a new kind of global variable for our hash table, which is static in my opinion, because only this files, variables and stuff can access it. I don't want other files to access it, of course. And then I'm gonna call it entry. Then I'll be like, no, not an entry, of course. It's gonna be a hash table, and the hash table is gonna be called ht, and I'm gonna initialize it right now. I'll go with size should be 0, count should be 0, and the entries should be null. I think that's true for now. And then what I'm gonna do is, okay, right now we have the hash table as a global kind of variable. We know we're gonna store it there, but let's create a function which is going to which is going to initialize the table for the first time for us. I'll make it integer as a return type because I want to return 0 or 1. And if it is 0, it means that there was an error. If it is 1, it means the hash table is created successfully. And I'm going to call it init table, no arguments. And then I'm going to just try to create my hash table actually. The way I'm going to do that is, first I have to check if I have not actually created it before. Yeah, I have to check if the hash table is not created. So if by mistake I just call this function 2 times, it's gonna be idempotent kind of thing. Like it's not gonna reinitialize it, and then it's gonna probably cause data loss if we reinitialize it. So if it is not null, I'm gonna be like return 0, and return 0 means like we couldn't create the table. We couldn't initialize it. By default, I have to return 1 because it should be a successful kind of scenario if we just reach to the end of that function. And then what I'm going to do is I will do ht.size equals, okay. Now here is the time to create a new actually constant variable, and I'm gonna call it init table size. So for the first time, I want it to be 4, right? And then I'm gonna use that when I initialize our table for the first time. So init table size, that's true. And then the count, of course, which is 0 by default. I want it to be still 0, I would say. I can even skip writing this. Let me just keep it here. Maybe I'll need it later. And then I will, I have to allocate memory for my entries. And I'm going to do like ht entries equals calloc. And there I'm going to be, how long should it be? I would go with size of, I would say, entry. And what is the second argument? I don't know really. It is the size of it. Oh, then it should be the other way around. I would say it should be ht.size and then their size of entry, if I'm not mistaken. Entry, yeah. So now we have the entries. I mean, we have allocated memory for our entries. And the reason we're using calloc here is that we want zeroed memories. When you use malloc, so you can get garbage memory, you can get garbage data. When you are specifying or allocating a memory to a program, it's possible that Previously, there were some data in that slot, and then if you're allocating memory again using malloc, then you can just allocate that memory without zeroing your those slots, and you can get garbage values. So when I use calloc, it means that I'm pretty much sure the memory that I'm allocating to this entry is going to be zeroed. That's it. And now I have to do a for loop, probably. Int I equals 0, I should be less than hd size, and I will increment I. And what I'm going to do here is that hd entries i's state should be empty, I guess. And hd entries i's key should be null. Yeah, and hd entries value should be also null. That's what I'm going to do. What else should I do here? I don't think I really have to do anything else. I'm just allocating it, creating the initialized kind of values for state key and value. And that's it. I don't think I have anything else to do, actually. So now, the reason that I'm not making this static is that because I want to use it in my main. So if I come to the main.c, first of all, I have to add this to the header file of that, like this. And once I have that, I can simply come to main.c and initialize my table. So I'll do init table and int is table initialized. If not, I can just terminate my program and say printf error init table. So we know that there was an error when we were initializing the table. Fine. And return, of course. I cannot return. I can just do return 1 because I have to terminate with status 1. Okay, that's fine. Until now, everything looks good. And let's go back to the hash table.c. And what should I do here? Okay, now here's the point. I have to create a function called, it's going to be an integer. No, let me just make it a static double because it can be a double actually. Yeah. You're going to notice why. And then I'm going to call it get load factor. And there, what I'm going to do is I will return, I'll consider the hd dot count, I would say. No, yeah, count to the size. Yeah, I will divide count. Let me think. I'll go count divided by double hd size. Yeah. This is going to be something like a double number, probably if it is filled. I mean, if the hash table is filled 60%, it should be like 0.6. And then I know that, okay, what is the load factor? And based on that, I'm going to decide if I have to resize it or not. And for me, the threshold is going to be something like 0.6 or 0.65 or 0.67. Sorry, 0.7. You can just put it whatever you want, but for me, for now, I go with a 0.6 or 7. And there we have the get load factor, exactly. And here, right before I insert anything to my hash table, I will go with if get load factor is actually greater than 0.6 or 0.7. Let's go with 0.7 for now. I will resize the table, and then continue. But I will leave it just like that for now, because I have to implement the resizing function as well. I'm gonna go with static integer resize table, or let's say extend table. And what I'm gonna do there is, first of all, I have to copy some stuff from the current table that I have, and then based on that copied data, I will create a new table, let's say, but now with a double size of the first one, and then I'm gonna copy the first entries to the new one. So that's why I need a copy of everything, I would say. So I'm gonna go with int old size equals ht.size. Yeah. And I'll go with also count or old count. Do I need old count? No, actually, I don't need the old count. I'll go with entries equals, or let's go with old entries. Old entries equals ht.entries. That's fine. And now I will try to create a new, actually, hash table. And the way I'm going to do that is, because I have copied the existing ones, so I can just completely free it up at the end of this function, and probably also, yeah, I can free it. Never mind. So I'm going to go with ht.entries equals, again, I'm going to calloc based on this time times 2, because I want to extend it. I want to double the size, and still the size of each entry is going to be size of entry. I'll go with that. And once I do that, I know, oh, by the way, here I think I have to check if ht entries is null. Then I know something wrong has happened, right? Yeah, exactly. So I have to do that as well. It shouldn't be null because we're calculating a memory for it. And here I'm gonna do the same. Like if the ht.entries is null, I'm gonna return 0 because something wrong has happened. So the calculation was not successful. Right after I do that, now I have to try to go over the old entries and insert them or reinsert them, not reinsert them, insert them into the new table. Yeah, let's do that. So for int I equals 0, and then until I is less than old size, increment I by 1, and if old entries I and state is occupied, I know it's not a free slot, and there I'm going to simply insert, I'm going to use the same insert function that I have. I'm going to insert the old entries I's key, and the same here, old entries I's value. Once I do that, I know that I am just reinserting them into the new one. Yeah, exactly. That's correct. And once I do that, let me just also do something like int result equals if result is not correct. Should I skip it for now? Yeah, let me skip it for now. That's not really important. And at the end of our function, of course, I have to return 1, meaning everything was successful. But also I have to free the old entries, actually. Am I right? I have to free that. And probably I have to free... Can I also free the old size? No. It's not a heap. Yeah, let's see what is the telescope diagnostics. It says... Where is it? Where's that error? There's no error? Yeah, let's just... I don't know if I really have to free the... Because that's in the stack, right? It is by default going outside of the scope of that function and automatically probably being removed. I'm going to ask that from ChatGPT to learn it together. So for now, I'm just freeing the old entries memory. That's that. And here I'll go with extend table. True, and then I'll continue with it. But now we have some errors that we have to fix them. This time we're not dealing with table size anymore. We're dealing with HD size. So HD size. HD size. HD size. And here I'm going to go with HD entries, of course. And go down, go down, go down. The same applies here. HD size. Also this one. And here entries. Let's go down. Let's go down here. HD size. Here HD entries. That should be fine. Yeah. Now I want a way. That I also write down something like a log to see what was the size previously and what it extended to. So I'll go with info, the table size extended from this to this. And there I'm gonna be like old size, HD size. That's what I need for now. And the insertion should work now. The search should work also. And let's just go with it for now. I don't think there shouldn't be an error with it. And in the main, I shouldn't really change anything. Let's just compile it to see how it works. Make it compile directly. And I'm gonna go with main at name emod at city Amsterdam at car I don't know, like something, add 1 2 add 2 4 error at unsuccessful. Okay, so we're actually not extending the table. We're not extending the table, and we have to find out why. The reason can be get load factor. Load factor is okay. Let's just print this here. Print f. The load factor is, and there I'm gonna be like d and get load factor. I don't think I can do this. I have to search for it. clang double print f format. Format a specifier for that is f. Okay. Get load factor, and here f. Load factor should be, yeah. Let's test it now. Make run main, add 1 2. Load factor is that. Add I don't know, 2 2. Why the load factor is not being increased. Ooh, I'm not keeping track of the count, guys. Very stupid mistake. So when I'm inserting, actually, at the end of insertion, if that was correct, I have to say ht.count. Oh, sorry. Increase ht.count. Otherwise, you're not keeping track of your count, which is a factor in the equation of calculating the load factor. So now it should work. I can, I think, just remove the log as well, because I'm pretty much sure that's the issue. Yeah, this one should be removed. Make re. Add 1, 2. Add 2, 2. Oh, sorry. Add 2, 3. Add, oh, also there's this issue that you can just add a empty value there, and that should be accepted, right? Like if I say get to 2, it should be 2. It's weird, right? So I don't know how that is 2, but we can just tackle that later as well. So add 3, 3. And the table size extended from 4 to 4. Let me check the code again. The table size, all size, HT size. But also this time, when creating, okay, I have to redo that section again. Of course, I have to initialize the values. Exactly, I have to initialize the values in there. The HD something. And here I'll do HD size. Even before that, I'll do it HD size equals old size times 2. And here I can just say HD size now. And HD count should be 0 as well. Once I do that, this time it should work. So make re main, and there add 1, 2, add 2, 2, add 3, 2, add 4, 2. The table size extended from 4 to 8, exactly. And so it means that it is extending it in the correct way. So if I say get 2, it knows it's 2. If I say get 4, get 1, of course we did the wrong thing. That was we added 2s as the value, so we really don't know if that works. But if I do it like this, I see it's not working, because when I'm adding 3 as key and value as 8, when I'm getting it, I'm getting still 2. So somewhere it's wrong still. Let's take a look at the code again. What can be the issue? In a table size is being used. Am I using this anywhere else, this table size, by any chance? I'm not sure. Make re. Nope, I'm not using. That's good. We can just delete it. But there should be a reason, actually. We are initializing the table, first of all, in the main C, I would say. Yeah, like this. And then we are simply putting ht.size into the init table size, which is 4. And then the count was by default here is like 0, so I would just leave it. I can delete this part, I would say. And then ht entries equals calc ht size of entry, exactly. If ht.entries equals null, meaning that we have not like allocated the memory correctly, return 0. And then I'm doing a for loop to initialize the first like values of each properties of our entries. empty null value null, and I return 1. And then there's this function that calculates the load factor. That is fine. The extension of table can have a problem actually. So I copy an old size here, and then I double the size of the current one. I do ht.count equals 0, and why 0? Yeah, because we don't have anything anymore. Exactly. And if it is null, return 0. Can return 0, right? I'm not sure if this is correct. Check here. Let me add this int result. If not result, then I'm gonna be like, okay, print 0 and print f error extending table. If I add more logs, I can debug it in an easier way, let's say. Okay, and then what am I doing? I'm just emptying everything, putting all to null and empty, and then I'm looping over all the entries, and if I find an occupied one, I just take that and insert it again. Where? Here, because I think then that's gonna have a is it gonna be like an infinite loop? I don't think so, because I'm recalling insert here, and insert is going to check this, but because the count is now 0 based on here, get load factor is going to result in 0, right? So it's gonna just continue, and by continue I mean like it's going to do the probbing again and add everything there. That's correct. So let me think. Old entries, I key in the value, and then I am freeing the old entries because I don't need them. Exactly. Let me put the table size to 2, or I'll go with 3 for now. And I don't know. I don't know what's the issue. Let's go with make re again, main, add 1, 2, add 2, 3, add 3, 4, add, how come it's not extending anymore? Table size extended from 3 to 6, okay. And now if I say get 3, I'll get 4. And if I say get 1, I'll get correct 1, get 4, 5, okay. Add 6, 6, 7, add 7, 8. The table size is extended, so get 7, 8, get 6. But what was the issue that we had? Was it my fault or get 1? It's working now. What did I change? Nothing almost. It's working now. It's weird. Let me create a new command here. And I'll be like cmd print, right? I need that because I want to be able to print our, let me copy this, hash table. And if it is print, just do cmd print. And Go down, go down, go down. Here, I have to add a case for cmd print. And there, it's going to be really easy. And I'll be like print table. That's it. Break. Okay. Make re main. Now if I do print, I have empty, 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 right? If I say add 1, 2, if I say print, it's key 1, value 2, right? Add name Emad, add city Amsterdam, and now if I do print, I see all of them are occupied. But how come the size is 3 and the count is 3 and 3 divided by 3 is 1 and it's more than it's greater than 0.7 and it's not resizing the table. That's weird, really. If I go with add car BMW, it's now extended. If I say print, I see still all of our values and keys like add something print. And if I say get sum, get name, get car, it works correctly. And just one more add, I don't know, like 10, 11. The table is resized, print. Now if I say get sum, it's working, right? I don't know what was that issue previously that it gave me the wrong value, but I think that was my fault by entering a wrong, probably, value because I missed adding a value for one of the keys. Maybe that's the reason. Let me go back to the code. I want to enhance some parts. So the first part that I want to enhance is that when I come to insert, right? I want to make sure my value is always there. I'm gonna check like if print the value is s and value like that. I want to check if I don't add a value, what I receive there. Is it gonna be null or what? Add name. It's at sign. At sign. Print. It's at sign. It's like, how come it's at sign? I don't know. Maybe that's a standard kind of way of showing an empty string. So that if I say add 1, nothing, print, get 1, okay. If I say 11, print, get 11. I don't know how I can reproduce that bug, but it seems it's gone. I don't know, but I've not really changed anything. It's weird. I'll keep it as it is because the whole goal for us was to be able to extend our table. The shrinking can be handled probably later because this video is almost going too long. It's 38 minutes now. But something that I want to just recheck is that I have to make sure the memory allocation is being done correctly and we don't have any memory leaks. And if I have one, because it's really hard, I want to show you how we can get use of AI models like LLMs to find out and debug some stuff because they're faster than us and they can just really help me. They can really help us in lots of, let's say, dirty kind of debugging. So let's run the program first of all. And I will create a new terminal and I'll use heap command to trace my memory leaks probably. No, sorry, for seeing that how much memory I'm actually allocating. So for now, I have 185 nodes, 185 nodes. Approximately it is occupying 17,632 bytes of the memory. And I guess that's the non-object section. here, but let's see if what happens. I mean, if I add some stuff and extend my table, add 1, 2, add 2, 2, add 2, add 3, 4, let's say, add 4, 5, and now the table is extended. We can just get rid of those locks, but that's not really important for now. And now if I run the same one, you will see that now from 185, where was it? From 185, it is extended to 211 with more bytes allocated. And the reason I'm saying that that's probably the non-object section, because if you check here, it was 11,264 and now it's 11,760. So it's increased. So we see that we're actually doing the extension in the memory. But there's this command called licks also. You can use Walgrind in Linux, but on macOS it's really hard to use it. So I'm gonna go with licks, and I'm gonna just trace my licks of our application, which I see we have 15 licks in our program, which is not a good thing. But I guess I can just find out where am I actually leaking those memories. So for me, whenever I am duplicating something like this string, probably I can simply, am I correct? I can simply just free them, or no? So is it correct to say free key? I don't think so. And free value. I don't think that's gonna work. It has a warning actually. Telescope diagnostics. And here it's like concierge, passing concierge, yeah. Okay, I'm not really familiar with the freeing stuff. Let me search or ask ChatGPT regarding that. Should I free a memory I use when I do str.dup in clang? Thinking, yes, you should. Does a malloc under the hood? Exactly, I know that. And but what is the reason that when I do this, but I cannot really free. Okay, let me show this to ChatGPT. Did I copy? How about in this case? Can it cause memory leaks? This is the learning phase. I do. Can cause leaks. The specific block once is not a leak by itself. For a single incident to an empty slot, allocates memory. Allocates memory. You store the both pointers in there. As long as you eventually call free before that entry is discarded. When you delete the key or destroy the... No. Actually, I shouldn't really... So that's not the part. We're not destroying the hash table. Oh, that's fine. That's fine. Where leaks do happen? You'll leak memory if you never free at all. Program keeps running. You keep inserting new keys. Heap usage grows. Forever you overwrite an occupied entry without freeing first. You only insert when empty, so you're currently safe from over. Yeah, exactly. But if you ever write code like this, no, we're not overwriting. That's not the functionality that we have. Error between the two str.dup calls. How? You should free this before returning an error. am I sending an error somewhere? No. I'll copy the whole file. That's the part I told you. For me, it's like, let me a better eye find it for me. This is the whole file. Tell me, where can I leak memory? Where can possibly I leak memory? Should wait still. The big one, extending the table, leaks all old strings. What happens here? Each old entry that key and value was allocated with str.dop earlier. During resize, you first call insert with those strings. Insert does another str.dop for both key and value. So now you have new allocations in the new table. Then you do free this. This only frees the area of entry, not the strings. Okay. I get you now. I get you now. So here I have to say free old entries I dot key. Exactly, and I have to do the same for the value because those were used or those were assigned with str.dop. That's the whole reason, and that uses malloc behind the scenes. Let me just do make re. Oh, by the way, I have to run the program here again, and then I'll do leaks. That was the whole leaks that we had. I get it. So let me explain it. The point was that when I'm doing free old entries, this is only freeing the array kind of thing of the entries, but not the key and values which were assigned with str.dop here. And str.dop behind the scenes uses malloc that allocates a memory for it on the heap, and that's the reason that we have to free them once we don't need them anymore. So even if you just remove your arrays, you're forgetting to remove the key and values from your memory to free it up. I mean, that was the whole reason. That was the whole leaking thing that we had. I think we just did it. There's just a tiny bug probably somewhere here, but I guess that's because I'm using a prime number. Is that a good reason? Let's go with 4, for example, and then see if the extension happens correctly. So I'll go and do make re, and I'll do main. Let me also remove that stupid lock because I don't need that anymore. No, not that one, not that one. Nope, nope, nope. There's a part which I've forgotten to do a... Oh, I'm in the main. I have to take a look at here. Print F. No. But why is the reason that I get some stupid logs? Let me check the whole file again. I don't see any stupid logs anymore. Error extending table. Yeah. Okay. I don't know why. But I go with make re, and then I'm gonna run our program, and I'll be like add 1, 2, add 2, 3, add 3, 4, add 4, 5, and then here's the point. So the size was 4, right? And 3 divided by 4 is like 0.75. And it's greater than 0.7. So why it's not extending the table? That's a good also probably question to ask from GPT. Learn from it. And another question, given my init table size is 4, why in the how many times I did it? On the fourth insertion, yeah. Why in the fourth insertion I get the table resized? Because 3 divided by 4 is or equals 0.75, and that is greater than, of course, 7, but the table is not extended at that point. Good question, and the answer is simple. You check the load factor before inserting the new element, so I have to do +1. No, but at that point it is already 3, and 3 is okay. Uh, initial size is 4. You insert items one by one, step by step. So the 0 load is 0, and no resize. Second, okay. Here, insert 3. Okay. I get what it means. So I have to always say probably count +1 because like this. Or I can just extract this and put it here maybe. Does that work? That should work. And if I do make re and main add, what happened? Add 1, 2, add 2, 3, add 3, 4. Okay, now it works. That was the whole point. I was checking the load factor before insertion, and that was the point. Cool. I don't think we have any other things to do in this episode. It's almost 55 minutes that we're doing coding. I was just trying to show you how I think about this stuff, how I use GPT, how I code, how I don't know, think about weird functionalities of like programs, and then I think I've done it completely, and I covered everything that I've promised in the previous session. So for the next one, probably we have to think about I don't know, shrinking as well. So when you have lesser key values, but there we have to implement the deletion functionality as well. So when you delete, you have to check if you have to shrink your table, but that's the exactly other way around of the thing that we just implemented. It's just resizing it to a smaller one and then doing the same insertion and hashing everything again. So it shouldn't be a really hard one. You can even try it yourself. But for the next one, we probably will think about shrinking or also a query language that we can implement something like not an SQL kind of thing, but just a simple one to find some stuff from our database based on the values, not only the keys. And that shouldn't be a difficult one. It should be a really easy one in terms of, probably we're going to tackle some B tree kind of things, but for now, I think we've implemented the very MVP kind of thing that we were aiming for in the first session. But let's just brainstorm in the next session and see how we want to continue this project. Thank you very much, and hope you see you next time.